Okay, so I'm gonna get going. Thank you everybody for coming. The sign-in that you did sign that went around is not only a sign-in so we knew who came, but also a release because our wonderful Stephanie is recording it, and then we'll put it through their YouTube stuff. We'll link it to our website so that people can view it in the future and that type of thing because it's good information for everybody. So I will go ahead and jump into it. We have a nice sized group today, and so as we go through it, you can ask questions. I don't mind getting interrupted as we're going along, but then there will definitely be time at the end of it for any questions and that you have. So, yeah, go ahead. It's pretty much the introduction. I think most of you know me, but I'm Craig Dawson. I'm Director of Energy and Environmental Health and Safety here on campus. I've been here for, I don't know, over 16 years, for quite a while. Next one. So we're talking about lead today. And what is lead? Many people have played with it and used it. Steve just oh, there you are. Steve has spent a lot of time with what this looks like to me, which it almost looks like a lead pig. We use lead in a lot of different places on campus, not only in our operations as part of equipment and other things, which is why we're always so big on recycling electronics and making sure that we get those back so they don't go into the landfill. But it's also used in a lot of our coatings, and I'll get into that more as I go through the discussion. But as far as what it is, it's got a low melting point. It's actually got a pretty low vaporizing point. It vaporizes at about 1,000 degrees, and so for a metal, that's pretty low. And then it's got these qualities as far as bendability. It works very well for containing certain types of alpha and radioactive waves and things like that. So it's got a lot of uses. So where it's been commonly used in the past, and any of us that are a little bit older now, which I always have to put myself in the category of, but is I certainly remember when it was used in gasoline, and that was one of the biggest uses, and I was actually a mechanic in those days, and it was a big concern of how we were going to possibly live without it because it worked as a lubricant in the engine, and so they had to do different things to be able to phase that out of the gasoline. But that was over time one of our biggest sources. You could think about along highways and huge interchanges and stuff, especially in some of the inner cities, and that how much of that exhaust can build up over time on the soil. Smelting, the biggest use now of lead in the country and really in the world is lead acid batteries. We use a huge amount here for our IT folks for the UPC backup batteries and car batteries and all sorts of things like that. There's a lot of new technologies coming out in that we won't get into because a lot of them are even way more hazardous, but that's one of their primary uses. And then paint, coating, solders, and all of those types of things as well. So in the late 50s, they started phasing them out of residential use. By 78, the Consumer Product Safety Commission had really pushed for in residential that they get below 600 parts per million for the paint that was used in the houses, because again, that's where so much of the exposure has come from over time. But something that's important that everybody doesn't have an awareness of or keep in mind is that lead paint is still being used today in shipping industries, on a lot of steel that's manufactured, products and pieces that we still buy today, and things that go into especially buildings like the Student Center and that. Normally things that you can't get to in contact, but structural components in that still use that as an industrial coating. Okay. So as we moved along in the 50s, you could pretty much, oh yeah, Pat.
Just a follow-up question. What was the parts per million before this?
It could be anything. They can go well up into the thousands, tens of thousands parts per million. They really quickly get up into percentages as opposed to parts per million.
And wasn't it like an average or standard
No, it was across the board based on the application. And some of the things that you would think would be the most benign, like white paints, clear varnishes on wood floors, were oftentimes some of the highest numbers that were well up into the tens of thousands. So in the 50s, you pretty much can be assured that you're going to have lead paint inside and outside on painted surfaces. 50s and 60s, it starts to narrow down a little. There's still a lot on the inside as far as trims and doors and things like that. And then when you get up to 78 is where you really start seeing the cutoff, and that's where we kind of use as our basic cutoff, although we still do some testing on newer buildings than that if we're going to do renovations and that type of thing. When you finally get to a point where it's less likely that you're going to run into the lead. As far as what, and this kind of goes a little bit back to what you were asking about, Pat, there's a lot of different definitions of what is lead-containing paint, what is a hazardous waste that has lead in it, and all of these different ways of viewing it. What's the concentration that's okay in the air, and all of these types of things. And so just kind of focusing on the paint, because for our general folks that work on campus here and that don't work with the lead paint material or don't have it in specific applications in their work areas, these are the ones that most closely associate to what you're doing. So EPA has the 5,000 parts per million, or the 0.5%, as far as the concentration in the paints that start to become more regulated. But then there's always the sides from OSHA, which is OSHA is concerned about protecting the worker, the people that are actually dealing with the material. There's no limit as far as how low it goes, and there's some very interesting interpretations on both that and asbestos that are somewhat challenging sometimes in the industrial hygiene world to do the amount of sampling and that's necessary to make sure that you're safeguarding people, especially when you're talking about very new buildings that everybody knows don't contain it, but there still are some requirements for doing verifications. So it's somewhat interesting there. So where can it be on campus? On the left here is one of our lovely little pumps that's still in action today that runs the hot water through the campus from our central plant and heats buildings for us. The coatings and paints in those types of areas are almost guaranteed to contain lead, and even on newer equipment is almost assured to have some levels of lead on it. On the right is a very typical, just a white wall. The color's not critical whether it's going to contain lead or not, but more often than not, the darker the color is, especially the greens and blues, the more likely on the older locations that they will contain lead. And so again, that 78 year kind of becomes important, and anything newer that we buy, especially from our local vendor and that our folks apply, has, since close to the 78 time frame, has not been lead containing. We use regular latex paints that are free of any type of those materials.
On the pump, I'm assuming the lead paint's on the outside only, not on the inside being pushed through campus.
Correct.
Just want to clarify everything.
Yes, the outside paint. The only place that we have issue with lead, and we're a distributor, and it's kind of a good point or time for a sidebar for that. We're a producer and distributor of our own water on campus, and so we pump it out of the ground, we disinfect it, and we distribute it to campus. And so as part of that process, we do very extensive monitoring and sampling of the water throughout campus to make sure that it meets all the standards, and we have a consumer confidence report that is posted online each year in that. In the Cabernet complex, which is one of our older complexes, and of course it's always, all of you are familiar with the state process and the low bidder challenges and everything. That complex, that village was built just before you weren't allowed to use lead solder anymore. And so it was being phased out at that time, and so it was probably a nice deal for whoever the low bid contractor was that built that building. But it's been this long, and we're just starting to see one or two spot areas where we have had a detection of lead in the drinking water there. So things are posted out there. There's specific protocols where people run their water for a certain amount of time. We've gone an extra step, or I should say housing has gone an extra step and put Brita filters on all of the kitchen sinks so that there's an additional option there. And we're hoping by next year that village gets completely remodeled, which will replace all of that piping. But we do continuous monitoring for those types of things to ensure that the water quality in that is good. So the buildings and the years on campus, just to kind of associate to what can have, and this pairs very, very closely to asbestos as well. And I didn't want to cover asbestos because it would just make it too long of a workshop for today, but I can always do another one if there's interest for it. But these are the dates that the buildings were originally built, and then if there was a renovation, it's listed on the right side. When we do renovations of buildings on campus, we really renovate down to the structural members, and Darwin is a good example. Salazar is another good example. They're literally driving skid loaders and things like that through the buildings while they're under renovation. It's just the structural pieces that maintain. And so at those times, we make every effort that we can to have all of the hazardous materials abated out of those buildings so it's not a burden for us managing them and people working on them going forward. And so, you know, we always come up to the struggles of cost and benefit. So there are a couple places in Darwin that we have identified that are behind sheetrock walls that are structural concrete pillars that still do have lead-containing paint on them. But it didn't make any financial sense to go to the extent and the cost to remove to that level. But we really go to a great length to remove as much as we can. So again, these will be posted online along with the whole presentation. So if you're ever curious about the age of the different buildings and facilities, you'll be able to see it on here. So now we're going to go into the health hazards of what the material can do and the threats of it. So the two basic routes of exposure for lead is inhalation and ingestion. Inhalation really comes from when it gets airborne and you breathe in respirable dust and it gets taken up by your blood. And ingestion is really from swallowing. With children, the biggest thing over time has been the lead paint chips and that type of thing around their homes. And with workers, it's more often than not poor personal hygiene. In other words, they're not washing their hands well after they're doing activities that involve lead, or they're having sandwiches, or I always pick on the cigarette smokers. They go out for a quick cigarette break without washing their hands when they've been doing tasks that have lead involved. And so that's some of the biggest ways that you get the exposures. When I was chatting with Jennifer just before the class, and she's from County Health, and she brought some stuff that you're welcome to look at after, especially if you've got kids and that type of thing on the childhood lead prevention, because of course children are the most susceptible group for lead, and they take it up into their bodies, and during the developmental stages it has a far more profound and long-term impact and more easily impacted than us as adults. But there is information up there about it. And so we were discussing, you know, even these days, you know, little giveaways, inexpensive toys. You were mentioning, I think, a Reebok giveaway from somebody. You buy a shoe and you get this little bracelet thing. That the levels of lead in a lot of those types of things are, you know, I've seen a lot of reports where they're actually high enough to be considered a hazardous material.
Absolutely. And a child died from swallowing a bracelet from Reebok that came with the shoes, and it sat in their stomach and leached out lead in their system, and the child died several days later with seizures, and it was pretty awful. They couldn't figure out what was wrong with the kid before the child almost died.
So, I mean, there's a lot of safeguarding, and we're focusing on all of us as adults and people that work on this campus, but I always try to bring, you know, that personal side in as well. And one of the biggest exposures I learned a couple years ago for children in our area for lead exposure is actually our keys. And, you know, you have your little infant and, oh yes, just be quiet, play with this thing and that type of thing, and they'll suck on the keys. And there's a lot of different, especially with our fancy electronic cars and that, there's a lot of different types of metals, including lead, that can be on those keys. So just to kind of throw that out there in case you have kids to, you know, kind of get you thinking in that direction. Health effects, lead, again, I mentioned this, it gets into your bloodstream if it's eaten or inhaled. Spreads throughout your body. It gets excreted or passed through your body to some extent, but then to some extent it accumulates in your body, and especially in certain types of organs and in your teeth and bones, which especially for pregnant women or women that may have worked in an industry, soldering industry and that, and then gone on to have children later, when all of the hormonal changes and weight changes and everything happen with that, it can oftentimes cause a release or a glut of that material from a long time ago to get into your system, and so that can be a big concern. And one of the biggest things with the second bullet here is continued exposure is the most detrimental and most hazardous types of situations. Those keys, they have the toys that are same, you have a house that's got paint that's chipping on it. You get a little dorky when you work in the environment I do, and I just got back from a camping trip, and I've got pictures. I went to Bodie Ghost Town, and I've got pictures of the window putty that they use on all the windows that was all friable asbestos, and the paints that there's almost no paint left, but I guarantee from that era was all paint. So if we took samples of the ground, I guarantee we could find percentages and that type of thing. It's just, you know, it's really important to be cognizant of where it can come from so that you don't find yourself in a situation with ongoing exposures. You know, I've finally gotten enough money and I've bought my Victorian house. I'm going to spend the next 10 years remodeling it. It's a wonderful thing. Just make sure that you're going through it in a way that you keep yourself healthy. So prolonged chronic exposures basically can affect most everything, and as Jennifer had mentioned with the children especially, can definitely lead to death. So can affect brain, kidneys. We hear a lot about, especially in younger children. I think they normally focus on 5 or 6 to younger for IQ impacts.
It's usually around 2. They should have had 2 blood tests if they're getting government assistance, but we see them all the way up to 18, depending on, you know, what their
Situation and
yeah.
demographics.
Mm-hmm.
So you can see it's very impacting. I mentioned a couple of these already with the reproductive systems and that.
Absolutely. And they say now that lead can cause severe reproductive harm. You may not be able to have children if you've had severe exposure very young.
So more chronic effects, severe damage to the blood, forming nervous system, urinary, loss of appetite. It goes through the whole cadre of things, which in my industry, you know, not that any of this is funny or laughable, but it's kind of the joke of, I've got half of those symptoms. Oh no, you know, type of thing. But that's one of the challenges with this and with a lot of actual diseases that are bacterial or viral based is they do present themselves so often initially as other types of things, and they often will get missed for those types of reasons. And so, again, real important to know your area and what you've got going on. Okay. Reproductive, again, both in men and women. It's not just something that affects women that can be affected. And again, these are normally occupational, larger exposures. Okay. Hypertension, blood levels of less, and now we start to get into a little bit of numbers, and you'll see a little bit more numbers, especially depending on questions you might have. But 20 micrograms per deciliter is what I would consider in this day and age a pretty high level for our area. It's not something that you would expect to see.
And it was the norm in the 60s. 18 was the average blood lead level of most adults in the 60s was 18.
Wow, I didn't know that. And I do recall from reading and preparing for this presentation that the average across, at least across the U.S., it's higher worldwide, is 1.38.
It's much lower, yeah.
Which
Little spikes here and there.
which actually even requires some specialized blood sampling because the normal detection limit is 2 on that. So that's a real plus for us, and another one of those fortunate things about the country we're in. Okay. So other chronic effects, low, moderate levels of lead exposure, been associated with adverse changes in kidney function, and it just goes on and on from there. Hypertension plays into diabetes and all those types of things. Acute health exposure or acute health effects when you're really getting high exposures, and I've underlined the extremely high amounts there, is when you really get into these types of examples that are much more susceptible for children, but certainly possible, not impossible, for adults to experience, is clear up to seizures and death and that type of thing. Okay, so enough of the doom and gloom portion of it. What do we have here, and what do you do or should you do as a part of the campus community to help us manage it and make sure that everybody stays safe with it? Identification is the most important part. And Tom Sargent, that wasn't able to be here today, is our specialist in the arena, and he's obtained certifications in lead inspections and other areas. And when you have any type of construction activity or modification to an area, or you see damage in an area, we have a whole range of a crew of maintenance folks that have been trained on what we call O&M, or operations and maintenance. So they can just come in, and if it's a small area, they can assume that it's either asbestos containing or lead containing, and do certain work procedures, which are primarily keeping things wet and contained and that type of thing, and do repairs. Two, if we're going to do bigger remodels, or we're going to hang big things on the wall that need structural support and things like that, then we'll actually run tests and send those samples to the labs to definitively know whether there's material there or not. One of the big caveats that I want to put in here, and I know it's a real important one for Thomas, and we don't want anyone to get confused about it, is we are trying to put more and more information on our website so that people can see and understand more and more of what we do have around. And so we are now maintaining asbestos and lead sample results that have been collected on campus over time on our website. The very important thing to know about that, and trying to see if it was on this slide or if it's on another slide, but the thing that's very important is that it takes a skilled, trained person to know and understand that, okay, we're wanting to do a remodel on this wall, and they'll have more of an ability to be able to look at that wall and say, okay, this was all painted at the same time, so I can take X number of samples, and that's going to be representative of what this wall looks like. Or look at it closer and notice that there's some damage in a spot, or the colors don't quite match or something, and recognize that it may have been applied at a different time or in a different manner. So now you have to sample both of those different areas to make sure that the material's not there. So it gets very involved. So the biggest takeaway from that is, just because you're doing something maybe in a given room and you happen to be a researcher type person, and you've looked on that list and you say, oh, look, there's been samples taken in this room before and they were non-detect. So I must be good to go and take off with whatever you want to do. Don't make that assumption. Still go through our process and make sure that we identify exactly for the scope of work that you want to do. So again, like I mentioned, building becomes damaged. The major or predominant areas that you worry about damage, where it may release, either asbestos or lead or anything like that, is from floors, walls, ceilings, and components like that. Especially if you're seeing peeling paint. We had lunch in a place that was a perfect example. I just didn't transfer the picture over soon enough, but dark green paint, older building, where it's just big chunks are starting to peel from the ceiling. We put extra covers down before we put our plates down on the table and ate quickly and left type of thing. So you still see those things around, but our folks do a really good job of maintaining the campus, and a lot of it is just about letting us know as soon or if you see something in these areas. I mentioned the part if anything needs to be modified, or even if you're wanting to do something simple like hang pictures and that type of thing. These things aren't just all about the lead and asbestos. They also fall into other general safety areas of, hanging a picture sounds simple, but is the picture going to be possibly above a waiting area where students may be sitting? And that anchor that you've put in the wall isn't sturdy enough for whatever that picture was. And we have a small shaker or something happens and that picture falls on a person and things like that. So it's just very important to go through that work order system and go through customer service so that the folks that are trained on doing these types of installations and on that type of work can be the ones that actually do that, so that we can have the highest level of confidence that it's done properly and that it's going to hold up for the amount of time we need. And the conclusions are fairly straightforward, but we do a lot of work to maintain the buildings in good condition. A lot of people over time will ask, why don't you just remove all of it? All of the lead, all the asbestos, all the hazardous stuff, and be done with it and then move on. It's just incredibly, one, expensive, and two, it's not practical in the sense that a lot of those materials, especially the asbestos materials that they originally had, are some really good stuff. I mean, whether they have bad materials in them or not, they're very solid materials. They really stand the test of time depending on where they are and how they're being used. We have a lot of components here that have been in place since the 60s that are still doing their job just as good as when they were first installed. And so as long as we are able to manage it, check the different materials and make sure that they're maintained in a good condition where they're not going to become an issue for any of us, then we're in a very good state with those. And so that's what we tried to do, and like I mentioned earlier, when we do those bigger renovations, we really do take that opportunity to remove everything from those facilities if the structure itself is still going to stand as we build back out.
Can you give a couple examples
Of
things that are still good quality but may still have some stuff?
well, the thermal system insulation is one of the biggest examples, but that's usually in mechanical rooms and usually not in spaces that people can get to. In some of the buildings, it may be above drop ceilings and that's the insulation. Paints on the soffits around the PE building, as well as underneath the penthouse on this building, on the Commons, and on Stevens. All of those were originally painted with lead-containing paint, and so when they were redone, again, it doesn't make financial sense to try and strip them down to bare metal and then paint them. Anything that's loose is cleaned and cleared off of it, and then it's painted over to, one, repaint and get the surface we need so it looks better, but two, it also helps to encapsulate or trap that material. But then that becomes an important piece for us to note and take record of, because when we do get to a renovation point, that's something that we need to keep in mind. And that's one of the biggest things that's been, I know, my pet peeve, and we've got a lot of great facility support to avoid doing this these days, but happened a lot in the past, was with the flooring. A lot of the vinyl asbestos tile, the small 9x9 tiles in Stevenson and Carson and Nichols is asbestos containing, and what facilities was getting in the habit of, just to try and be economical and save some money, was to lay carpet over the top of those tiles. It's nice from a perspective that then you're not touching the tiles, and we've done a lot of work in the last year or so to build up our waxes and materials to protect our tiles so that they don't become impacted. But what ultimately happens is then when you do go to remove that material, you're now spending 2 or 3 times the disposal cost, because all of that tile is going to be stuck to that glue down carpet, and there's no way to separate it for disposal purposes. And so we really, even though it's an added cost for people that want to put carpet in a room or do something along those lines, we really try and encourage and push people to have that tile removed and have the glue underneath removed, so that we're at a clean slate in that room and it won't be a bigger burden later on. Yeah.
So the last room I was in Stevenson, when we remodeled, they put carpet down over carpet, which I think was laid down over tile. Is there, do you have a threshold for how many layers of carpet you put down before you decide to take the whole thing up?
The easiest answer for me is that's not my area. You know, ultimately you could trim the bottom of the door so it still opens and doesn't hit your flooring, but I don't know. I'm not familiar with your particular situation or how that came to be. But like I say, we just, you know, from the pure EH&S perspective, we just really kind of push and encourage everybody. This is what it is, and this is what the baggage is, and please don't look at it for, well, I'm only going to be in this office for 5 or 10 more years, and then I'm either retiring or moving or doing whatever. But think about it for, you know, we're an institution. We're not going anywhere. All of us are just stewards for the amount of time we're here. We're passing it on to somebody else. And so, you know, let's leave them as little baggage possible. So I hope that helps. I hope that helps. Doesn't really answer your question, but I don't know.
Yeah, so from here on out anyway, or under your tour, you are highly recommending tile to be taken out if the carpet's going to be put down.
Yes, unless of course it's just an area rug that's not adhered to the floor. But yes, when it gets adhered, it becomes that whole issue of now you've got a bunch more waste when you ultimately have to deal with
That
it.
just means on that job, it's going to cost more and take longer.
Yeah. Yep, once they actually go to remove all of the layers. But, you know, we can look at the upside, and there's a good chance they could pull the 2 carpets apart at least. But that'll all remain to be seen. Any other questions? I think this is just, you know, again, a very obvious type of thing, that one of the things that we come across often, but again, it's not in general access areas, but is in more mechanical rooms and things like that. We have a lot of small transformers that reduce voltages from one level to another that are gray, and they get peeling paint on them, and those are lead containing as well. And so our maintenance folks have actually gotten very versed at dealing with those as far as scraping them, and we don't try to, again, fully strip them. We're just getting the loose material off, because the flaking and loose material is what we're trying to prevent, so it's not getting out into the environment. And so, you know, again, it's really those types of things that you're concerned about and want to keep an eye on. Where else could you find it? I mentioned this because back in a previous life when I was a consultant and was doing a lot of work for Sun Microsystems at that time, we were doing a lot of air sampling for what they call a solder dross operation. Basically, they were doing kind kind of tabletop printed circuit board type of manufacturing. And the manufacturing part was fine, and all the air sampling was fine on that, but we wanted to investigate their cleaning operations and what happened there and all of that type of thing. Well, it was an interesting process because through part of that process we did multiple types of blood sampling. We did what they call zinc protoporphin, and which gives you more of an indicator of long-term exposure, and then direct blood sampling, which gives you an indication of shorter-term 30 or 60-day type of blood exposure. And it was very challenging for the particular group that we were working with because of the demographics of them and because their diet was heavily fish. A lot of them had some pretty significant lead levels in their blood even outside of the work environment. And so it made it very tricky to separate those types of things out. And so I put this up here just so you can kind of be cognizant of just a taste or a sampling of some of the other sources where these materials can come from and be an exposure to you associated to. Yeah?
Don't forget brass fixtures in older homes.
Don't forget what?
Mention brass fixtures in older homes too.
I did not know brass fixtures. Older brass tends to contain a lot of lead? Great, thank you. So, you know, those antique roadshow things, I mean, I'll admit it, I'm a DIY addict. I'm always watching all those silly shows. And, you know, that's, again, that dorky side of my mind, that's where that's always going to, is when they're grabbing these old pieces of furniture or old fixtures and stuff, and we just sand them down and just do this and that, and
Well,
it'll
I'm
be...
talking specifically about in water-based, like on your faucets and things.
Oh, for the lead that's actually going to come through in the water.
Yes.
Oh, thank you. Very good to know.
Internal components sometimes.
Yes.
Especially in like your account and stuff.
And fortunately on campus we have no issues with those types of things because we really do try to change out and have lower flow and all of those types of things, except in those specific older locations that I've mentioned where we've had a couple detects, and hopefully we'll have all that resolved. But that's one of the big things is the information that does get sent out and is posted on the websites and that type of thing for the campus really tries to share any of that pertinent information as it comes up. Okay. All right. So now we're to the question part. Any other questions that anybody has about the programs and that we have on campus? And like I say, if you're interested in other topics, asbestos is extremely similar to lead as far as the way it's managed, as far as the age of buildings that have the material and that type of thing. But I'm happy to discuss that one as well, or other types of topics if they come up. Just, you know, funnel the request back to me, and I'm happy to set those up.
I was just wondering what precipitated this discussion or this talk. Why is it part of the series that you're going to be?
No, this was actually a request through a settlement with the CSUEU. And so they wanted more training and more transparency and more information put out. So
Training your workers?
no, just for general population. Is that a fair enough synopsis?
That covers it pretty well.
Okay. All right, any other questions? Oh, yes.
Just as a general question to cover the topic. I have staff in some buildings that have been remodeled and some buildings that have been remodeled. So as a general understanding from someone who has limited knowledge on this topic, it appears safe to assume that generally the buildings are just fine.
Oh, yes.
A common problem we might have in Darwin are damp ceiling tiles that fall down. Dampness is a problem in Darwin. We deal with a lot of fluids. Those ceiling tiles falling down are not an issue.
No, they're all, in fact, at this point, and don't hold me to a Bible on this, but outside of the glue-on tiles in the restrooms in certain buildings like Stevenson and probably Nichols, all of the drop ceiling tiles that we know of, which are those ones on the T-bars that you can just lift and move out of the way, have now been
you're gonna seal tiles rather than take them all up, knowing that sometime in the future, some of them will be remodeled.
Right.
So if we're in an area such as Nichols, where it's an old building, some work needs to be done, you're recommending, don't hang that picture yourself, call somebody, because we know there's potential issues in the building.
Yeah. It's a very, very good summary. Okay, any other questions? Oh, see,
What are the recommended lead solder substitutes for ROH components?
I would have to look into that. Off the cuff, I don't know. I'm assuming you're still using ones that are percentage lead for your operations. And I think
Yeah,
for,
yeah.
and I think for printed circuit board, which is still, you know, going back to that electronic waste thing, is still a huge component. And I'd be happy to look into what some of the substitutes are. But, you know, with all of those things, there's probably going to be some give and take from a cost, from an effectiveness, from an operational standpoint, and all of those types of things. But I'd be happy to look into that.
And the general term for this is ISO 9000 compliance, or is there a term for lead-free?
No, it's just a direction, you know, like with asbestos and like with a lot of other materials over time, it's been recognized as the problem, the prevalent problem that it has become, and how much we've used it. So it's just a phasing out of it.
There's no generic term, safety term.
No. Nope. Okay, great. Well, thank you very much, everybody. Have a good afternoon.